Hello everyone. Now today we are going to see the numerical methods used for solving the gear train problems. So basically you know what do you mean by gear train? Gear train is a combination of gears which is basically used to transmit the motion. So here the gear trains, there are different types of gear trains such as simple, then compound, then reverted and epicyclic gear train. So what is the basic difference between simple, compound, reverted and epicyclic gear train? So if you see here, in this case for simple, then reverted and compound gear train, the position of the gears, they are fixed. But for the epicyclic gear train, this is one wheel, this is another wheel, and both of these wheels, they are now attached with the help of arm. So each of the wheels will be having relative motion with respect to each other. So our first method, that is tabular method for solving the gear train problem, is applicable for epicyclic gear train. So now in this case, for the epicyclic gear train, if you see here, the gear A, that is called as the sun gear, to which input is given. Then your gear B is the output gear from which you are getting the output. But this gear A and gear B, they are now connected with the help of this arm C, which will be having relative motion with respect to fulcrum point O1 and O2. Means if you try to give clockwise motion to this gear A, then the gear B will be having anti-clockwise sense of rotation and the arm is free to rotate. So the arm will also rotate with respect to this fulcrum point O1. So this is the basic difference for the epicyclic gear train as compared to simple, compound and reverted gear train. Now what is this tabular method? If you see here, now first condition, there are four conditions for solving the problems of epicyclic gear train. The first condition is what? You have to fix the gear A. Means you have to first of all fix the gear A. And how gear A is fixed? By fixing the arm. Means here the gear A is fixed. Means here there will be no any rotary motion to gear A. So now here, if you before going in detail of the conditions, we will see what are the columns. So these are the four steps we have to follow. Then these are the conditions given to that epicyclic gear train. Then here there are the number of elements. So how many elements are there now here? So there are three basic elements. That is, first is gear A, then second is gear B, and third is your arm C. While putting that element name in the table, you have to first of all put the name arm. Means you have to start with arm. Then to which element gear you are giving input, that gear, and from which gear you are getting the output. So here first of all first step is what you have to fix the arm. So here arm C is now fixed, and you have to just rotate the gear A. Means to particular to the gear to which input is given, you have to rotate it by +1 rotation. Okay, so here clockwise sense of rotation is plus and anti-clockwise sense of rotation is minus. So you have to fix the arm, this C, and you have to give +1 rotation to gear A. So now if you see in the table, so arm C is fixed. So motion of the arm is fixed. So it is 0. Gear A is given +1 rotation. And here the speed means if you just give clockwise motion to this A, then the B will move in anti-clockwise sense of rotation. And you know that anti-clockwise sense of rotation is minus. So it will be minus number of teeth on A to the number of teeth on B. Means here speed ratio is directly proportional to the PCD. And PCD is directly proportional to the number of teeth. PCD is nothing but pitch circle diameter. Here there will be sense of rotation of gear B will be anti-clockwise. So minus sign is given here. So minus sign is given here. So now here minus sign is due to because your gear B is anti-clockwise sense of rotation. Now what is the second step? Here now you have to fix, means here arm is fixed. Means this epicyclic gear train is now completely converted to simple gear train. Arm is fixed and gear A, instead of giving +1 rotation, here we are giving +x. So here +x means this A will be having clockwise motion. So if it is having +x motion, then here the gear B will also in terms of x. So you have to multiply x to this term. So minus x into TA by TB. Then third step is you have to add y revolution to all elements. Means here, first of all, x motion is given to A, but in that case, arm was fixed. Now here you have to add y revolutions to all elements. It may be A, it may be C, and it also be B. So it will be +y, +y, +y because it is clockwise sense. Then the last step is what? You have to just do the summation of second number step and third number step. So here it will be y, here it will be x plus y, and it will be y minus x into ta by tb. So in this way, you can find the number of motions, the number of revolutions given to each and every element for the epicyclic gear train. So this is the tabular method which is used for solving the problems. Means in the problem, you will be given PCD or number of teeth. Then you will be having the the number of elements which are present in the epicyclic gear train. Then afterwards you will be having either of the motions given to input or output. And from that you have to prepare this table, and from this table you have to get each and every motion of elements. Now the next slide is what? It is the next method is algebraic method. So what is this algebraic method? So algebraic method, the motion of each element in this epicyclic gear train related to arm is set down in the form of equations. So here the number of equations depend upon the number of elements present in the gear train. So here now if there are now, for example, here we in the first case there are two gears, so we'll be having two equations. Now in this case, two conditions are usually supplied in the epicyclic gear train. That is, some of the elements they are fixed and some of them they are having motion. Means in the first case, in the previous slide we have seen that arm was fixed, then gearway was given motion. But for the other problems, it may be another condition. So here for the first, means if you consider the first diagram, if you see here, let the arm C, means that arm is fixed for this algebraic method. So speed of A related to arm C will be given as Na minus Nc. Means it is fixed, so it is positive, so Na minus Nc. And speed of gear with respect to C is Nb minus Nc. And since these gears A and B, they are meshing directly, so their motion will be opposite. Means A will be having positive sense of rotation and B will be having negative sense of rotation. So here, in terms of number of teeth ratio, it will be given as Nb by Nc upon Na minus Nc is equal to minus Ta by Tv. And here arm is fixed, so the speed of the arm will be equal to 0. So you have to substitute this value in this equation, so that you will be directly getting this equation as what? Nb by 0 means Nb by Nc minus 1 is equal to minus Ta by Tv. So either of these two equations will be getting from this tabular method. So this tabular method is easier. Tabular method is easier so as to solve the problems as compared to as compared to this what is it? Algebraic method, because in this case we have to find each and every condition, each and every equation of a gear pair. So this algebraic method is not much more easier as compared to tabular method. So for solving the problems of this epicyclic gear train, we will be using tabular method only. Thank you.